Hello and welcome to Thinking with Objects, lecture number 3, subclasses. So last time we, both did last lecture, we took a look on classes, how to use them, what they could be used for, some examples, and so on. But we're still missing a lot when it comes to classes. It's this lecture and the next lecture is also going to speak about classes, and this lecture is about subclasses. So subclasses allows us to create classes based on other classes. But before I get to that point, I'm going to start with an example. It takes about 10 minutes, and then I'm going to expand it with subclasses after those 10 minutes. Okay, so let's get going in Dr. Java here. So what I want to do is have a class called public class doorway, and this doorway is going to have two rooms connected to it, and then you can tell a user, a person, to pass through between the door, between one room and the other room through the doorway. And then we're going to make a subclasses to this doorway here. And for this to work, I've already prepared a class called room, which is quite simple. It just contains the different doorways of the room. And I also prepared a person class that we're going to use. Afterwards, you can take a look on them if you want to on the lecture page. They will all be uploaded there. Well, they are there already, actually. Okay, so we need a constructor for the doorway, and I'm simply just going to ask it for two rooms like this. I could have them in an array, but since I just have two rooms and the knowledge of what I'm going to use them for, I don't think it's worth putting them in an array. It wouldn't really help. It would be the same amount of code anyways, and I think it's easier to just do it this way. Oops, room 1. So first of all, I'm just going to save them like this. So I'll save them into the fields to be able to use the rooms for later on. But also I want to do something else, which is the following: add doorway like this. So like I said, I'll prepare the room class, and one method there is called add doorway, and then I can give it this doorway, and that means that the first room and the second room will now know that there's a doorway in that specific room, connected to that specific room. So we can later on get a list of all the different doorways to be able to see, well, if we are in a room, then we can sort of check where we can go. So that's something already added in there. And what do we need to do with the doorway? Well, it's quite simple. It's just public void go through like that. And what do we want to go through? Well, the person, like so. Right, so how do we go through a doorway from one point to the other? Well, first of all, we need to be able to get the opposite room. So I'm going to define this here, and I'm going to make it public because, well, I need it later on to sort of tell us which room is on the other side of a doorway, which is good when we print out options and so on. But it's quite simple to just check if this specific room that we give in the parameter is find the opposite to it. So if that room is the same as the first room, and then if that's the case, then we want to return the second room. So if we're currently in room number 1, then we want to return room number 2 because that's the one on the other side. But if we're currently in room number 2, I can't spell room 2. If that's the case, then we want to return room number 1. So we just return the opposite room because that's what we want, to get opposite room. However, if we're not in any of those rooms, something is weird. That means that, well, you're trying to get the opposite room from a room that is not adjacent to this doorway. So then we just return null. Like that. And then when we use get opposite room in here, we can do like room target. So here's the target we want to move to. Like that. And then we just use person.getRoom. So there's a method in person that returns the current room we're in. Okay? So we use that, get the opposite room, and that's the target room. That's the room we want to go to. And as long as target is not equals to null, that we actually find a room that we want to go to, we can just set that as the new room for the person, like so. And otherwise we can just print out, well, this didn't really work out, did it? So this person is not near this doorway, which is a nice way of saying, well, you did something terribly wrong. Okay, so at the moment that's actually it for this simple doorway class. I'm going to extend it and add some more to it, but what we have now is a constructor where we get 2 rooms that we save, but we also add the doorway to those things, and then we have a method called go through, so we can go through this doorway as well as get the opposite room for a specific room. Okay, so let's now use this in a example. So now we do public class room example. Okay, so how this is going to work is like the following. We want the user to be able to enter some input. So it's all about having the user in a specific room, and then we will list all the rooms that are adjacent to our room, and then we can ask the user which room do you want to go to. And therefore we can use doorways, we can check which doorways do we have, and then we check which room is on the other side. Okay, so public static void main, like always. Like this. So as you can see, there's no subclasses here yet. There's nothing new. But I'm going to give us a small solid base, and then we're going to extend that by adding subclasses to it. So first of all, I want a new scanner. So that's quite simple to be used later. And then I want a hallway. So I create a new room, and the room class is defined so it has one constructor with one string as the parameter, and that's just the name of it. So hallway here. So we create a hallway, and then we've created person. So that's the user. The person takes 2 parameters. First, a name for it. I'm going to name it Steve, and the second one is which room to start in. So we start in the hallway. That makes sense. We're in the hallway, you know. Right. And what we then can do is, for instance, loop forever. That seems like a good idea. And each time we get here, we go into print out the well, the username, user.getName. So that one's current location, and then we get the getRoom.getName. So there's something in a specific room called getName, and that's used, well, to get a name we specified in the beginning, which in the hallway's case is just hallway. Right, and then when we've done that, we can ask the user where it wants to go. Print line, where would you like to go? And I know I misspelled that, typo, like so. And then it's just a matter of looping through these ones. So I'm going to use a for loop, but I'm going to add the well, declare the variable up there, so I can use it later. And there's something in a room called getDoorwayCount. So we can get the different doorways from a specific room, and that's what we make sure that we can by adding them to the actual room, like that. Right. So when we've done this, it's just a matter of grabbing the doorway equals user.getRoom get doorway at that specific index. And as you can see, we start with index 1, and that's just how everything is set up. So the first door is actually index 1, and the reason why I want to be able to do that is so I can print out, well, option 1 is door 1, option 2 is door 2, and so on. Room target, so then we want to see where we're heading if we would go through this doorway, which is just the opposite opposite room from the room the user is currently in. And that's where I wanted to use this method again. That's the method we created in here, get opposite room. And finally we can print out the option, which is the number and then some space in between there, and then the target's name. So that's the room we're heading towards. And when we printed out all those options, we can just print out the exit option, so we can exit the program. And the reason why I put I outside here is so I can now print out exit as the next command after all the doorways. So it doesn't matter how many doorways I have, the next option will always be exit. And now it's just a matter of actually checking what the user wants to do. Like this. So first of all we check if the option is greater than or equals to 1, and if option is lesser than or equals to user get room dot get doorway count. So if that's the case, that means that we have a valid door because it's a valid index. Otherwise, if option equals I, that means that we hit exit because we printed out, well, I is the exit, the thing we typed to exit it out. So therefore, if that's the case, then we want to break out of the loop. Or if something else was entered, then we print out, well, this was an invalid option. Like that. And finally, we can do something like this. So if we get the selected doorway, like this. So if we selected a doorway, which means, well, we selected an integer in this specific range, then we can just get that specific doorway, and we do it similarly to when we wanted to get its name here. So it's user.get room dot get, what is it, doorway, like that, and then we supply it with option. And now it's just a matter of it couldn't really be easier. We just tell the selected doorway that we want to go through it with the current user, like this. Nothing too special. So now if I hit compile this example here and run it, we will see where would you like to go. Well, Steve's current location, hallway, where would you like to go? And the only option we have is to exit. So why is that? Well, we have no other rooms and we have no doorways at all. So let's add some rooms. I prepared a few here. So let's add, living room, kitchen, dining room, and a bathroom. And then I'm going to add some doorways between these. So I'm adding one between the hallway and the living room, one between the hallway and the kitchen, one between the kitchen and the dining room, and one between living room, dining room, and finally a hallway and bathroom. So what we get is basically a little loop where we can go from hallway to living room to dining room to kitchen and back to hallway, and then we have the bathroom as well. So now if I hit compile, however, and run it like this, I get it like this. So Steve's current location, hallway, where would you like to go? I want to go to the living room. Steve's current location is the living room, where would you like to go? Well, I can go back to the hallway, I can go to the kitchen, dining room, living room, and finally end up back in the hallway. So that's totally fine. I'm just going there, and then I can go to the bathroom because you have to poop sometimes. So I go to the bathroom. There's a problem, however. There's just a doorway. There's no door. It's just a doorway. You just go through it to the bathroom. So I'm sitting there minding my own business, and all of a sudden our guests appear in the hallway. We invited them for dinner. And well, there's no door. So it's just a doorway which we can go through, which is one part we need. We want to have a doorway, and then we want to have two rooms, one room at each side. But obviously, well, when we go between the kitchen and the living room, it's fine. It's fine that if we don't have a specific door, we just have a doorway to go through. But between the hallway and the bathroom, it will be quite nice to have a door. So let's take a look at what we can do about it. So what we've had so far is this class called a doorway. We created something, a doorway from it called, well, not called, but we had a method called go through, which we could use to allow a person to go through it. That's the most important part of a doorway, that you can go from one room to the other But what we can do, this lecture is called Subclasses after all, is to create a subclass called door. And what that's going to mean, if we create a subclass from our doorway, that's going to mean that everything that we have in our doorway, all our methods or all our fields and everything, will still be a part of door. So we will, if we create a door instead of a doorway, then we will still be able to go through it to the other side. We will still be able to get your room on the other side, and all those things. But we can also add more things to it, like open door, close door, check if it's open, and things like that. And then if we do it like that, then we can create a door here. And I've written down the methods open, close, and is open. But note that even though we do this, we create a subclass called door. Even though we do that, we can still create doorways without a problem, and they will just contain the simple doorway. Whereas if we create a door, it will contain everything from a doorway, but also the specific things for the door. So how do we make a subclass in Java? Well, let's start doing one. So I'm going to call it public class door. I think that makes sense for a name for a door. And what I want to do now is extends doorway. So this means that we have a door, that's our new class, but it means that we want to continue building on the doorway. So we get everything from the doorway as a part of this class, but then we continue and add methods and constructors and fields and whatever we want. So now if I do it like that, then obviously I will have to add a constructor, public door. That's not how you spell door. And when you create a door, you also need to specify which rooms that it's connecting it, well, like the two different rooms on the two different sides. So we still need to send these along. What do I do with them? Well, I'm not really too concerned about them here. I don't really care about what they do. But when I have this specific code for the doorway, then I need them, right? Like go through and things like that. So what I need to do is to send these along to the constructor of the doorway, this one here. And that's always the case. We have to call the constructor of the superclass. So the doorway is a superclass to door, because we extends doorway, and door is a subclass to doorway. So what we do then is we call the superclass like this and give it room 1 and room 2. And what's this going to do, and we have to do this in the beginning of the constructor, the first thing, and what that's going to do is to call this constructor here, run the code inside it, which will save these ones here, and then when that has been done, it's going to add this specific doorway to the different rooms. And then we can run the code in here. For instance, we may set that it's not open. Well, we don't have any field called that, so we can create that private boolean open. So all of a sudden we have something that is exactly the same, apart from one little thing. We have a field here called open. We're not using it, but that's exactly what we're going to. So I'm going to do protected boolean is open. And why am I using protected? Well, you will see later on in the end of this lecture. Okay, so I want to return open. So if we want to see if it's opened, then we can just check that by get the value there. And then we can tell it, well, I want you to open up. And we do so by setting open equals true. And then we can tell it to close as well. Protect void close, and close equal open equals false, like that. So now we have the same things that we have in doorway. Those still exist, so we can still go through here and we can still get the opposite room. But we can also check if it's open and open it and close it. So, well, when we are at a bathroom, it would be quite nice to be able to let's close that, to close the door behind us. So, well, when your guests are in the hallway, you're not supposed to wave to them. Right, so, but, well, let's check here. we have this go through, right? But you can't go through a door. You can go through an open door, like you go through the doorway where it is, but if it's closed, then it's closed, and it's closed for a reason, so nothing can come through. So what we can do, if we want to prevent the user from going through it, if the door is closed, then we can do go through person. And what's this going to do is, well, observe one thing. We have go through here, and that's exactly the same method name as this one, go through. We have a person here, and that's exactly the same parameter list as this one here, so person here. And what this means, if we have the exact same method in a subclass that we have in our superclass, that means that we're overriding it. And what that means is that we're not going to care about this method anymore. It's sort of going to disappear in some sense. So if we're going to ask the door to allow the user to go through, it's going to use this code here instead. Yes, there you go. So if we take a look on the following, so now I'm going to use the door here instead of the doorway and run it. Okay, so if I now try to go to the bathroom, I'm not going to get anywhere because, well, I call the go through one because I chose that door, but it's not doing anything because I said, well, go through, there's no code here. But if I use kitchen, like 2 there, I want to go through the doorway to the kitchen, and since that's just a doorway, I'm just going to end up in the kitchen, like so. But it's a bit weird to just remove all the code here, so what we might want to do is check if it's open. So if the door is open, we want to actually go through it properly, and otherwise we can print out, well, you can't go through a closed door. Silly. Something like that. Because, well, if the door is closed, it's closed. Open it first. But if it's open, what we can do is super.goThrough person. Right, so we used something called super up here when we wanted to call a constructor. So we called the constructor of the superclass, which is doorway. So we called this part here, so that was run like so. But we can also do super.aMethod name, and then just call that method. So what we're doing here is that we're calling this method here, go through, but the version we have in our superclass. And what this does is that, well, if the door is open, then we want to run the code like we would for any doorway, and therefore we are allowed to pass through. That person is allowed to pass through. But if it's not open, then we want to just print out that one. And as you can see here, we're not calling the super.goThrough, and therefore the user won't be able to go through. So now if I compile it and run it again, we will see that if I try to go to the bathroom, it's going to say you can't go through a closed door. Silly. We still don't have an option to open it. So it would be very nice if we had that, right? Yeah, I think so. So what I'm going to do is inside the door here, I want a method called approach door. So we can just add more methods here, approach door. And when we approach the door, we want to see which person we're approaching it with, but I also want a scanner to be able to like ask the user and get responses about, well, do you want to open the door, you know, things like that. Right, so the first question is actually, do you want to close the door? Because if, here we go, if the door is already open, then if you approach an open door, you might want to close it. Like you see, oh right, the front door is open, and maybe I should go there and close it. Or the bathroom door is open, I should close it. So if it's open when we approach it, we get the option to close it. Do you want to close this door? Like so. And then we get the option yes or no. Like that. Okay. And then if scanner, so that's the scanner we're reading from, get the next word, convert it to lowercase, and then compare it with yes. So if the user shows to close the door, then close the door, like so. So if it's open, ask the user if it's fine to close it, and if the user answered, well, I want to close it, then close it down. Then we can do the opposite, so if it's already closed, we can ask the user, do you want to open it? And if so, we can open the door. So far so good, right? Yeah, I believe so. So after we have done this, if the door is left open afterwards, after we have approached the door and done the first check here, so that means that we have either had the door open from the start and ignored to close it. We got the option, do you want to close it? And we said no. Or we might have had a closed door and it asked us if we wanted to open it, and then we opened it. So in any of those two cases, the door will be open in the end here. And if it's open, we might, well, approach it and go through it. So system.out.println, do you want to go through the open doorway? And then we get the same option. Yes. There you go. No. Like that. So we can either go through it or just leave it like it is. I'm going to use the same code here. And if we want to go through it, so the user said yes, then, well, we have a method for that, right? Person. Go through with a person. So then we're going to call this code, and since the door is open, we're going to call the super go through, which is this go through, which is going to do all the work, which is going to allow the user to actually go through the door. If we wanted to, we could do super.gothrough right away here. It wouldn't really make a difference, but I think it's good to just call the go through of that we have up here, because then if we want to do something specific there, we will actually pass through that method as well. Maybe we want to set something when we're walking through this thing, and I don't know. Right, and then afterwards, when we went through a door, we might want to close it afterwards. You know, you open the bathroom door, you enters the bathroom, and then you might want to close it afterwards. So yeah, you get some privacy. Do you want to close this door behind you? Like so. And if the user says yes, then we want to close it in the end, like that. So now we have a simple approach door method, which is just about asking the user, do you want to close it, open it, do you want to go through it, do you want to close it afterwards, and things like that. Right. But we're not using this. We're not using approach door. There's no method called to it. So we might want to do that from somewhere, like here. When we select a door, then we might want to approach it. But we select a doorway, and I can't really do selected doorway dot approach door user my scanner. That doesn't really work, because there's nothing, as the error here tells us. Oh right, yeah, sorry. So there's nothing called approach door here in the variable selected doorway of the type doorway, which is perfectly fine. It makes perfectly sense. There's nothing in here in the doorway class called approach door. There's, however, something in the door class called approach door, and that's the one we want to call. But there's nothing in the doorway, right? And what we have to make sure now is that we actually check if this doorway is as well a door, because the doorway we get here, that can be any doorway, that can be the door as well. So our code that we currently have works totally fine with the door as well, because the door extends doorway like that, and that means that the door is also a doorway, but that doesn't mean that a doorway is also a door, if that makes any sense. So what we can do then, if select a doorway, so that's the doorway we have, instance of door, and what that's going to give us is a boolean value if the selected door, the current value of selected door, is indeed a door as well. We can't do like selected door is instance of scanner, like that, because the selected door and scanner doesn't have anything to do with each other, like this. Actually, it's complaining that I misspelled that. Come on. But if we compile again, there you go. Inconvertible type, so we can't use doorway and the scanner together. Those are completely different types. But I can use door here for one single reason. Door extends doorway. So that means that if I have a doorway, like here, it might as well be a door, because there's a specific class called door. It's this one here, which is a specific type of a doorway, and therefore if we have just a bunch of doorways, we have a huge bag of doorways, then one of those doorways might be a door. We don't know that for sure. And if it is a doorway, it will contain extra information about if it's open, if it's well, how we go through it. We can approach the door. So therefore we just check if this is indeed a door, and if it's not a door, just approach and go through the doorway like that. So if it is a door, though, what do we want to do? As we saw, we couldn't just do selected doorway dot approach door. That didn't work. But what we can do is define a new variable called selected door, for instance, and store selected doorway there, right? And then do selected door equals not equals dot approach door user my scanner. So will this work? Not really. It's going to say incompatible types, where it requires a door but it found a doorway. So they are incompatible but they are comparable, right? So I can't just store this doorway here because I don't know for sure that this doorway is indeed a door. Well, I checked it there, but we can tell it to convert to a door by doing it like so. And this does work just because, well, door is a subtype of doorway. It's a subclass of doorway. But note, however, if we actually had a doorway, only a doorway, like one of these doorways up here, the one between the hallway and the living room, the hallway and the kitchen, if we had one of those instead of a proper door, then this code would crash, because it would say, alright, I can't convert this doorway, the selected doorway, to a door, because it's not a door. But that's why we check first if it's indeed a door. So first we check if it is a door, and if it's a door, then we want to actually grab the door part of it so we can approach that. So this is casting. We cast it to a door of that type, and I showed that actually in the very first lecture of the very first course. Right, so now we can just run that like so. So Steve's current location is hallway, and then we can go to living room, and then we can go back to the hallway. Totally fine. If we go to the bathroom, however, it's going to run the other code. So when we went to the living room, it checked if the selected doorway was of the type door as well, which it wasn't. It was just a simple plain doorway. It was that one, and therefore the code ran here, so we just went through there. However, when we wanted to go to the bathroom, the selected doorway, so remember, that's still a doorway, but we also found out that that doorway is indeed a door. To be more precise, it's a door. And then we grab the door part of it, we tell it, well, we have a door here, right? And then we approach the door, and therefore we get the option. Do you want to open this door? Yes, I want to open it. And do you want to go through? No, of course not. My pal was sitting there taking a, whatnot. So let's exit out there. So I got the option, do you want to open the door? Yes. Do you want to go through? No. And the reason why I wanted to do that was to add something more. Because at the moment I can't really tell if a door is opened or not. Okay? It just says bathroom. And I can't really just tell it like target plus target dot is opened. Like that. I can't really do that because, first of all, it's misspelled, but second of all, well, a doorway can't be open. It's like you can always go through it. So I could do something similar like I did here, but I think it would be much better to do something like target dot not get name, but we remove that and ask the doorway. So we have a doorway and then the room we want to go through, both those things. So like create a method called getLabel. So we get the label for the specific doorway when we go to this specific room. Okay. So where am I going with this? Well, if I then create that method in the doorway, public void, not void, am I silly or what? Gets public string get label, and then we use the room that we want to go through, and the default thing here is to return the name of the room. That's exactly what we did before. So if I compile it now, there won't be a difference. We just ask the doorway what's the name of this room, like this. Pretty straightforward. But however, we can override this, right? This is a method, a public method, and we can just override it in the door class here. So what I'm going to do is actually do public string get label, and then room. Then we can return get room dot get name, like this. So room dot get name. So that's the same thing that we had before. Or if we wanted to, we could do super dot get label room. So we just ask the superclass, the actual doorway, how would you print this out? Can I get that? So can you do some of the work for me? I don't want to work at all, I'm lazy. And then afterwards we want to add a tag afterwards depending on if the door is open or not. So if it's open, we want to add open, and otherwise we want to add close using this ternary operator here. Well, closed and opened is probably better, like so. There you go. So now, if this is indeed a door, rather than just a doorway, then we will use this get label instead. And when we use this get label, we're going to call the get label of the doorway and then add some extras afterwards. Sort of like we did with go through. We, if the condition here was true, then we wanted to go through like that, but otherwise we wanted to print something else. So here we go, get label, and hit compile them. And you might just have seen what I did. I sneaked in an S there, so all of a sudden it said get labels, and therefore we didn't override it. So therefore we get the default thing. We just get bathroom. It doesn't say if it's opened or closed, because like I said, I sneaked in an S here, and that basically made this to another method, and another method is not going to override our method. So what we can do is type override here. So let's type override on these two, because those are overriding other methods from the superclass. So what will this do? Will it override it anyways because I spelled wrong? Of course not. It didn't know what to override. But if I hit compile now, it's going to complain. It's going to say method does not override or implement a method from a supertype, and that means, well, you did something wrong. How do you fix this? Well, basically make sure that it is overriding something. So these override that you can add, they are not required to override anything, but they are very, very handy. Because then if you did something wrong and you think like, oh right, this is going to override the get label, and therefore I'm going to get a different text so I can see if it's open or closed, and then all of a sudden it's not showing up. Why it's not showing up? And then you might search the code for a long time and realize in the end, oh right, I spelled the name wrong here, or I added a parameter too much or whatnot. So it's very handy, because then we will get an error right away. There's something wrong here. You're not overriding things that you're telling me that you're supposed to. And if you're taking this course to be able to do Minecraft modding, then it's worth a lot to use @override, because in Minecraft modding, then a method might have changed if you update your Minecraft version, and then all of a sudden your code breaks without you realizing what. Then it's better to just throw an error like, oh right, this method is not overriding anything anymore. So it's very good to have it there, just for the compiler to tell us that, well, the method that you tells me that you're supposed to override something with that one is not actually overrunning anything. So it's a very handy thing to have. Right, so now we use the get label here properly, and we can run the code. As you can see now, we get the default get label from for the doorway, so that's the living room there and the kitchen there, whereas the bathroom get the default part here, but then we add closed because it's closed, or open if it would be open. So if I approach the bathroom and I want to open the door, my pal is sitting there, so I go back again. I left the door open though because I got so startled I wasn't prepared for him to be there. So now it says bathroom, it's opened. We're currently in the hallway, that's fine. We can go somewhere else. We went to the living room, but right, we left the door open. The pal was done there. He's done on the toilet. He brushed his teeth. I don't know what he did. So now let's approach here. Do you want to close this door? No, of course not. I want to enter. Do you want to go through the open doorway? Yes. Do you want to close the door behind you? No, of course not. So I'm just sitting there minding my own business with the bathroom door open. And the bathroom is just next to the hallway, which is just next to the door to the well, to the front yard. And then our guests arrive, and I'm sitting there minding my own business, you know. And they arrive in the hallway. I'll say hello, and oh right, I should close the door, right? Do you want to close this door? Yes. So there we go. So now I'm sitting there, finishing up, then washing my hands. Then I can open up. Do you open this door? Yes, of course. Do you want to go through this doorway? Yes, of course. And finally, do you want to close this door behind you? Yes. And finally, I can go to the kitchen to see if they need any help with the food. And oh right, they were done. Some mates had already prepared everything, and then we go to the dining room to eat and exit out of this madness. So right, so there we go. Now we have a doorway where we can go through normally, but we also have a subclass called the door, which, well, more than just be able to go through it, we can also open and close it, and we get some more options here with approach door here. So we ask the user, do you want to open, do you want to close, and so on. And then in the example here we check if it's indeed a door, then we want to use the more advanced options. Otherwise we just want to go through it right away. What if we want to add another room here called the outside? So yeah, I know that the outside is not really a room, but that depends a bit on your definition. If we think about it coding wise, then it can totally be a room. That's just a space there. And if we think about it as, well, room as a space in the three-dimensional pane, then we can totally use it as well. So I'm going to use a room here called outside, which has the name outside as well. And what I want to do is add a door there between the hallway and the outside. Right. Now we get into one problem. You probably want to lock this door, wouldn't you? So otherwise we would just leave it unlocked during the night, and whoever could just come in here and use our toilet or whatnot. That's probably the worst thing they can do, not steal anything or something like that. So it would be nice to have an ability to lock the door. So how would we do that? Well, the answer is subclasses, of course. But that's the topic after the break. So now we will take 50 minutes break, and then there will be 45 more minutes, but that's in about 50 minutes. I'll see you then.